talk about 100 years of lessons learned, what we learned during that time. My name is Bill Hazell. I'm the Asheville Field Office Chief for the Water Mission Area of the U.S. Geological Survey. And our office covers the 25 westernmost counties of North Carolina. And as such, I tell everybody I have the best job in the USGS. And I truly believe that. I've got a great field area to cover. I've got good staff, have opportunities to meet and talk to people like this. But along with that comes other things, such as going into areas right after floods, talking with people during those times, and that can be kind of tough. Overall, it can be rewarding, but sometimes people just want to talk to you, and they want to tell you about how high the water got, what they lost, what happened, what they were doing when it flooded. And sometimes I feel like my job is just to stop everything else I'm doing and just listen. And just this past year, I've been in South Carolina and Louisiana, and more recently West Virginia, to be in those areas after the big flooding they've had. And particularly just recently here in West Virginia, while planning for this event, the flooding they had up there reminded me a lot of, or had me thinking a lot of the flood of 1916, in that there were a lot of remote areas very heavily hit by the floodwaters. And 23 dead, over 25 schools damaged, over 100 churches damaged, thousands of people displaced, maybe even forever. So it was a tough situation up there, and the only thing that helped me out was seeing the big difference, I think, between their recent flooding and the 1916 flooding was the recovery. The advent of helicopters and an interstate road system, they got the supplies they needed a lot quicker than the people in 1916 did that were kind of left on their own. And after listening to all these stories, that recovery is one thing that really I took back with me, because when I first got there, I noticed one church in particular just had a parking lot full of trash and debris. They were dragging everything out of the building just so they could go in their house of worship and hose it down to clean it up. And I noticed the next day that pile of trash was a little bit smaller. And then by the third day it was quite a bit smaller, and I noticed another pile had started at the other end of the parking lot. And by the fourth and fifth day, the trash was all gone, and these pile of supplies was building and building, to where by the time I left, this church had been heavily flooded and lost everything inside, was now a major supply point for the community. They had traffic control, they had pallets of water, food, clothes, toys. These people had lost everything. And the same people that had just lost a lot themselves were now helping these people out. So that's something I really took away from me, took away from that. So part of what we do with the USGS is we collect a lot of data. And I know that looks like more of our geologic division potentially data there, but that is mean daily values for 120 years from our oldest stream gauge here on the eastern side of the Mississippi River, the Fresh Broad River at Asheville. It's one of the oldest gauges in the country. And it's located right down there on the Pearson Street Bridge, not far from where we're at right now. And you can see here, just in this table, the mean daily values, 1916 was obviously the highest. So we've got 120 years of data there. And it's higher than some of the other historical floods that were mentioned in the first panel as well. And some, I think everybody here probably remembers the 2004 floods. But in addition to that, we also have another 100 years of historical peak values, all going all the way back to 1796. And you can see where the 1916 flood stands on that as well. Far greater magnitude than anything in 220 years at this location. So that's just an idea to give you the magnitude of the event, and you'll hear more about that. But also, we're looking at 100 years of lessons learned. And that's what you're looking at right now on the screen, is 100 years of annual peak levels. And you can see 1916 is still the highest in that period as well. So we're going to talk about what we've learned. Experience is a great teacher, right? if you pay attention. So we're going to talk about, hopefully, in this next panel, lessons we've learned during that time. And while we're talking about that, some things I want y'all to keep in mind is, hopefully what have we learned? Awareness, preparation, mitigation. Mitigation, that's a word you're going to hear a lot in this panel. Response, just like the response was so different in West Virginia last week than it was 100 years ago in Asheville. And other topics as well that y'all may want to talk about with this panel. And what we're going to do is I'm going to introduce our first speaker, and he's got a very good presentation. He's way more interesting and has a lot better graphics than I do, so I think y'all will enjoy it. Yeah. And then we'll move on and to just have a panel discussion with the other members of the panel. So hopefully we'll have plenty of time to have questions amongst ourselves, questions from the group, and that type of thing. So our first speaker is Mr. Jim Fox. He's the director for UNC Asheville's National Environmental Modeling and Analysis Center. NEMAC uses visualization, GIS, web tools, and decision support tools to address key societal issues. These issues include forest health, climate, flood mitigation, there's that word right there, water resources, and future land use planning. They also utilize multiple forms of informal education, such as this meeting right here, to interact with the public and help local decision making and support economic development around the climate resilience sector. Several recent projects, including the U.S. Climate Resilience Toolkit for the White House and the National Oceanic and Atmospheric Agency. Jim holds a degree in geology and geophysics and communications. I think that'll stand out as well as a master's degree in information technology for informal education. He says his passion is utilizing community collaborations and leading edge technologies to aid in complex decision making. Did I get that right? You did. All right. So this is Jim Fox.
Well, thank you. Great set of talks to start off this morning. And what we're really talking about in this group is looking at moving from this idea of risk exposure and response to more building resilience. And how can we be more prepared so that when the next large disaster occurs, that we are much better prepared and can bounce back from that much more quickly. Well, who are we? We have a tagline from data to decisions. And so we work with huge amounts of data. But by and large, most of us in the room need that information distilled into some key visuals that actually apply to things that we care about. And so that's really what we specialize in. We also only can do our work through working with a large variety of partners. A university center like ours is at the intersection of academia, government, and private enterprise. And so you'll see then that from what we're doing, the idea of collaboration is really critical for us. So I'd really like to start off by thanking our partners. What you're going to be seeing would not be possible without this very large cast of characters. We work a lot with NOAA. I hope most of you know that we're very fortunate here in Asheville to be the home to the nation's weather and climate data center, NCEI. They're a great resource, and a lot of climate scientists that we work with and their expertise is here with us this morning as well too. It's also the location of the U.S. Forest Service Southern Research Station, so two great federal agencies that we partner with that are located here in Asheville. We also work a lot with local government. It's a pleasure to work with the City of Asheville, Buncombe County, and the Mountain Counties through our Council of Governments and several others as well there too. The part that is really a growing area for economic development element in our region as well too is this area of climate resilience. We've recently opened an office in downtown Asheville called the Collider, and a lot of groups coming together to be working on this type of information and providing the types of tools that you're going to be seeing today. And I'm actually going to be showing you some products from some of those companies that are creating these tools as well too, and how they're locally applicable. We have a large group of companies that we work with that are involved in this space. Esri, the world's leader in mapping and GIS technologies, several engineering firms, including Kimley Horn, and then a large group of others. And so the reason I want to give everybody credit for this is a very complex topic. And nobody can have the expertise to really be dealing with this by themselves. And so it's really the power of all of us together in a room like this for making these sorts of decisions that really has to come to bear. So these types of conversations and listening to people like you to tell us what's most important to you for making those decisions becomes a critical part of the conversation. Well, what do we know? These are some facts, and we can start with the facts. These sorts of heavy precipitation events that caused the 1916 floods will continue to happen. We know that to be a fact, and that's just kind of Mother Nature and where we live in the mountains. And we've heard a lot about the rivers coming up, but just as important for these type of things are the mountains coming down, right? The landslides and what that causes as well too, because when you look at the type of damage and the lives lost, that they're related just as much to the landslides as the floods. And so these heavy precipitation events that cause the floods also are the initiators for the landslides. And so we have to get back to this idea of these heavy precipitation events, and just as Bill was talking about, the severity of those, how severe 1916 was, but also the frequency of those, how often they occur as well too. And we also heard quite a bit in the first talks about the things that we value that are being impacted by these. And we have to then separate out the view of what those critical assets are and looking at response, recovery, resilience of each of these different ones. I thought that the speakers this morning did a great job about talking about the human dimension and looking at the infrastructure and how the economy needed to be bouncing back and what that cultural fabric was that would allow that to happen quickly. But also the infrastructure. We are very dependent on our supply chains. And that was one of the biggest things that we just didn't bounce back very quickly from, was the ability for our supply chains to come back. And so these are the sorts of things we're going to be talking about. So the questions that we want to answer, and I apologize for keeping turning around, but I only do well with my aides here. So when you start thinking about, what's the frequency and severity? Because I think that's one of the big questions is, are we going to get another 1916 type event? Yes, we are. It's just, when is it going to occur? And, what is that severity and how often are those occurring? So we want to be looking at that sort of question. And also, how's that going to be changing? What is the data telling us about what that trajectory is that we're on? But I think the bigger question that is being asked here too is, now that we know that we're going to be getting those things occurring, are we more resilient? What do we know now? What can we learn from history's past lessons? And how are we as a society prepared to be dealing with that? And to be really looking at being resilient around these things we care about. And so I want to talk a little bit about these concepts of vulnerability and risk and what we are doing as local governments, state governments, federal governments, to really be recognizing that we're exposed to these types of threats, but through very careful planning, we can actually be reducing the risk. So I think, the question was, and what we saw from the historian's talk this morning is, if we had another event like that, how long would it take us to recover and be back operational? And would it take us the same 20, 30, 50 years to actually get back to that point? So I want to talk about some basic concepts. And you heard about some of those, but maybe we can kind of see those and how they play out here in Western North Carolina. So first of all, this idea of we're all connected by the watershed. And a watershed is basically just a bowl, right? Think of putting your hands together and water coming into your hands. And the watershed is basically this large bowl. And if you turn your hands and you would think about how water is going to run out of those connected hands, you can think about just turning those down, and there's only one place out of that bowl, and that's between your fingers, right? Well, that's the idea of the watershed. And Asheville sits at the point of intersection of two of these tilted bowls. And that's where the Shenandoah and French Broad rivers come together. And so if you look at a map of Western North Carolina, we heard in the talk about the Blue Ridge Escarpment and then this green line, which is the Eastern Continental Divide. And basically the Eastern Continental Divide is the line where a raindrop that falls to the east of that green line, it's going to flow out to the Atlantic. A raindrop that falls to the western side of that green line is going to eventually flow into the Mississippi River and out into the Gulf of Mexico. But when you start looking at these two big watersheds that are going to be impacting Asheville, you can actually see that one outlined in orange, which is the upper French Broad, is everything that is upslope of Asheville. That's Henderson County, a lot of these areas. Any drop of rain that's falling there is going to come down the French Broad. The area outlined in red is the Shenandoah watershed from Black Mountain across to here. Again, anything that falls within that red is going to come down the Shenandoah. And where are they going to meet? In Asheville at Biltmore Village. Okay? So let's take a little bit of a look at just that red bowl so that you get a little bit better idea about what happens. This is then again zoomed in map of that area. The watershed is outlined here in this blue. You can see up north of Black Mountain is the North Fork Reservoir, all the streams running into that. They all come down into this blue line that's through the middle of the watershed. That's the Shenandoah River. You can see that all streams that are within that blue line are all coming together into the Shenandoah River, and the Shenandoah River comes down and comes right into Biltmore Village in Asheville. Now, if you look at the same area in 3D, so I'm now in a helicopter up above, and a virtual helicopter. This is some products that our partner Esri helps put out of being able to do this in full 3D. But we are now looking at this watershed, looking from Biltmore Village up dip, and you can see now that bowl shape, that everything that's inside that red line is going to come out in one point. Okay, so that's the first part of this. Now, if you look then also about slope, that we all know, living in the mountains here, that the flattest places that most of us have always lived are where? Next to the river, right? Those areas that are green are the flattest areas. That the red areas then, the darker red you get, those are actually more steep slopes. And so these bowls are not just flat bowls, they're pretty steep-sided bowls as well too. And so here in the mountains, you get these heavy precipitation events. You can either decide to be close to the river where the water is rising, or you can be on the side of the mountains where the mountainside's coming down. Okay? Well, it's not as severe as that, right? But the more people that live here, the more you're going to be looking at, well, where are we all going to live or do work? And you are caught between literally a rock and a hard place. Yeah. So the other part that we talk about is how rainfall actually falls during these heavy precipitation events. And you get a lot more rain on top of the mountains than you do down in the valleys. But most of our precipitation gauges are in the valleys where we live. And so again, when you start looking at these rainfall totals that are coming in and why the rainfall total at Alta Pass is so much greater than these others that we're seeing, is you get a lot more rain that's falling on top of the mountain. And that means that down in Asheville, we may not be seeing a lot of rain. That doesn't mean that there's not a lot of rain coming right into the watershed. And this is actually a rainfall map from the 2004 event. You know, in Asheville, we only had about 4 inches of rain. Up on Mount Mitchell, which is the top part there up above North Fork Reservoir, they had over 20 inches of rain. And so a large amount of differential rainfall, you know, but it's all coming into the bowl together. So these things all add together, and these are things that we cannot control. Okay? This is nature and where we live in the mountains and the beautiful place that it is, but these are things that are beyond our control. So let's talk about these heavy precipitation events, because it's the heavy precipitation events that lead to the flooding and landslides. Now, this is an interactive web tool that is created by a local company here. It's a commercial spinoff of NEMAC. It's called Fernleaf Interactive. But I want to give you an idea about what's happening here. That this is a map of our area, and let's see if I can get this to work. So this green dot is Hendersonville. Here's Fletcher. Asheville sitting through here. Brevard is here. We have historical precipitation data from Brevard, Hendersonville, Asheville, and then we've got the USGS stream gauge data located at Asheville. So what we've done is we have zoomed into 1916. And if you look at each of these three precipitation, the red line is showing as what is normal precipitation for the year. And so if your colored in pink area is underneath the red line, that means you're more in a period of drought. We're in a period of drought coming into the summer of 1916. Okay? Now you can also see on each of these precipitation graphs is the daily precipitation at that location. Those are those green lines. And you can actually start seeing then some very large rainfall amounts that start actually in late May. Now I want you to compare those three precipitation gauges and say, is the same thing happening in Asheville as it is in Brevard and Hendersonville? The scales, the vertical and horizontal scales, are exactly the same. So you can see what's happening, and this is normal for us. The city of Asheville, we get less than 40 inches of rain normal, average. But down around Brevard, they get closer to 80 to 100 inches of rain. So very large differential rainfall to start with in the upper part of the watershed. But you can see that actually the largest rainfall amounts in Brevard actually happened even before these hurricanes started. So the ground starts getting saturated, right? We don't have a lot of soil sitting through here. So late May, these heavy rains are starting in western North Carolina. And the local film that's made and is going to be showing some tomorrow, they've interviewed people and they said, yeah, you know, it just never cleared up. It just started in May and then just kept going on. Well, you can see then that as we move to July 8th through 10th, this is the first hurricane coming in. And now you can see what's happening is that we get a large amount of rain all across the area. You can see those green bars are happening in Brevard, they're happening in Hendersonville, they're happening even in Asheville. But you can look at the stream gauge sitting through here, and I'm sorry, hit the wrong button. The stream gauge, and it's still pretty much river flowing within its banks until that time, right? It's not until now, this July 15th and 16th, the hurricane from Charleston. But look at what's happening here. That there's not that much rain now in Brevard and Asheville, but look at what's happening in Hendersonville, right? You're getting just this deluge sitting through there. The talks this morning talked about the earthen dams breaking. A lot of those earthen dams were there to provide water for cooling for the industrial plants as well too. You needed steam generation to be running some of your plants and all there. You can't rely on wells for providing that water. So most of the industrial areas had to have their own reservoir for cooling water. And these dams started breaking. And you can see then what's happening here is everything comes downstream and comes into Asheville. And there is that peak flood event that's happening right there. Well, this is some work by Rick Wooten, North Carolina Geological Survey is here. And these heavy rainfall events also initiate landslides. And so you can see on this graph that this is this 1916 event sitting right through here, that you can start seeing the landslides are related to these 5-inch rainfall events. And when you start cresting over 5 inches of rain, you start getting large amounts of rainfall. And you can see, here are these landslide numbers and the correlation with the landslides. And you can then see historically, 1916, 1940, the 70s, 2004 event, even up into the present sitting through here as well too. That this is another map from Rick, and this is a work in progress, but he's showing the location of the large landslide events in red and where the heavy rainfall contours were, and you can see that they are centered, there around Transylvania and Henderson County here to the south. But you can also see, that these are these headwaters of the Catawba here in Caldwell County. They were getting a lot of that rain sitting there as well too. But when you start then looking at zooming in, and again, Rick Wooten's work, you can start seeing these landslide areas. And it's really important to be looking at this because when you start looking at loss of life, we hear the stories about the waters coming up in Asheville. But loss of life down through the years, we see just as many people losing their lives due to the mountainsides coming down. In fact, in the 2004 event, we actually had more loss of life due to the mountainsides coming down here than the waters coming up. So a really key point is heavy precipitation events lead to both types of disasters that you have to account for. And from an emergency management response, they have to be putting resources into both sides of that because they have to be putting the resources out there to respond to the waters coming up and the mountainsides coming down. So let's talk about the frequency and intensity of these heavy precipitation events. We see from the data that these type of events are increasing. Okay? So when you start looking at, is it likely that we're going to get another 1916 event? Yes. Is it more likely now than 100 years ago? Probably. So this is from the National Climate Assessment put out by the U.S. government. And you can see just from the data that the percentage change in these very heavy precipitation is happening. Here in the southeast, 26% change. Northeast is even greater, 74%. But we are seeing that we have greater heavy precipitation events that's happening in the historic record. And you can see then, and this is again data from NOAA and NCEI, that if you start looking at the total precipitation anomaly around Asheville, that you can start looking at this heaviest 1% rainfall that we're getting, and you can see from 1950 up to the present that these are increasing. And you can see that when you have these yellow bars going down, those are more these periods of drought. But you can see what's happening with these blue bars is we're really, stepping these up as well too. And the city of Asheville really had some major problems dealing with actually our wettest year on record here just 2 years ago now. So these sorts of things we are seeing happening more often. We've also talked about floods in these two different river basins. And so this is from USGS data. And these are floods of record. And you can see that the different colored bars. So, you know, if you listen to the National Weather Service during a heavy precipitation event, you know, how many of us have heard about, you know, the French Broad coming out of its banks? And where does that usually occur? Somewhere close to Mills River or whatever, right? Anytime we hear that sort of thing, we're starting to get this action stage, which is this green bar. If we start looking at flood, actually the water truly coming out of its banks, that's a yellow bar. A moderate flood is a red bar, and then a major flood is a dark red bar. Well, as we've heard from all the talks, you can see the 1916 flood was definitely a big red bar on both rivers. But you can see, though, that just due to this differential rainfall across the mountains, that the Swannanoa, which is this lower one, actually has more flood events and the major floods of, you know, the water coming out of the banks than the French Broad. And so Biltmore Village is, you know, much more exposed to the floods than, say, the River Arts District is as well, too. I do want to point out that when you start looking at these red and dark red bars, those are major floods. And you can hear sometimes in FEMA flood language, you know, the 100-year floodplain, that we're getting equivalents to 100-year floods about every 20 years. Okay? So frequency and severity, you know, this is a problem we're going to be dealing with. Now the question. Now that we know what Mother Nature is throwing at us and what it is, how are we as a society able to deal with that? Are we more resilient now than we were 100 years ago? Well, we've talked about some of these forces against, right? We are seeing these heavy precipitation events are increasing. We also know that we've put a lot more impervious surface into the watershed. In other words, we as building, you know, our society, we've paved over a lot more of the parking lot, right? Which means that even more water is going to run off during these heavy precipitation events than what would naturally occur. We also have put a lot more people in infrastructure in Western North Carolina than 1916. So we're putting a lot more stuff in harm's way, and we've definitely built a lot higher up on the slopes. And that means that also we're less locally resilient due to our dependence on our supply chains. Most of you know that you know, we do not produce very much of our local food. We don't produce our local energy. You know, if you look at our tourism economy, that really depends on tourists coming into the area. Any of us that have sat on either I-40 or I-26 at certain times of the day can tell you how much traffic comes in our supply chains. And so these are some things that are kind of going against us. But the forces that we have going for us is the thing that you're seeing here in the room is we're much more proactive in planning. And, you know, I would have to disagree a little bit with some of the talks this morning that, at least from what I've seen, the stakeholders are at the table. Now, yes, there are problems with continued funding and things, but I have seen our local government and the blue dot in the middle of the red sea, as I think it was discussed earlier. There's been good working together across those for building some local resilience. And so, and I think, you know, we've made a lot of strides about building in much more early warning and adaptive capacity as well, too. So we're recognizing the things that are against us, but we're being very proactive in trying to really reduce our vulnerability and risk. I do want to remind you that, you know, we've had this recent experience. 12 years ago, might not seem like that recent, but 2004, yes, very similar sort of thing, 2 tracking hurricanes, as in 1916, so they do occur. But what was important was the city and county came together and put together a flood mitigation task force and actually said, you know, what lesson can we learn from this? And it wasn't one of these top-down, here's what you're going to do. The city and county got together and brought a lot of the stakeholders to the table. Business owners in Biltmore Village, people from the county along the Swananoa, the town of Black Mountain, and really seriously talked about what do we need to be doing. Now, did they come up with perfect answers? No. When you bring a diverse group of stakeholders to the table, everybody's not going to be 100% pleased. But I think as far as a cohesive voice, and the important thing too was action was taken. And you're going to hear a lot more about that this afternoon. I want to showcase some of that. Now, one thing that we are getting a much better handle on is what's actually happening. And again, this is a new suite of tools that just keeps getting better and better. This is a full 3D model of our region. This is a partnership between Esri and UNC Asheville's NEMAC. But what we're beginning to really be able to see and understand is we can put all of these assets in place in full 3D and interact with it so that we can take things out of, ooh, what do you think's going on, to actually the data come together so you can actually see what's going on. And you can see these as the whole business district of Biltmore Village, along with the trees. The flood level is now fully integrated with the FEMA floodplain. As we know here in the mountains, these are not ponds, right? The rivers dip, and so this is a dipping floodplain layer that goes through here as well too. And we can really then start simulating these flood mitigation efforts that we're taking advantage of, like in Azalea Park and others, to see how we can actually be mitigating that flood. For the past 6 years, we've worked with Buncombe County and the city of Asheville on a multi-hazard risk tool. This is available to all of our citizens. You can go right into this into any individual parcel. This is the 100-year floodplain. Just to give you a little bit of an idea, here's the Swananoa coming in here around Biltmore Village. Here's the French Broad coming in, going from south to north, intersecting through here, the River Arts District. Here's I-40, here's the 240 loop, downtown Asheville sitting through here. It's one thing to know where the hazard is. It's another thing to then start saying, well, where are the things we care about? And so we're working with the city to be putting together the whole resilience plan, integrating with the whole future land use plan. And so you can see these are then every one of the parcels sitting through here. And they're color-coded in this instance of looking at property value. So you can actually looking at a direct impact and then doing the intersection of this hazard with the other, you can automatically generate reports. And you can start seeing then that we can separate out the types of parcels based on community services or residential or commercial, and how many parcels that you're actually seeing in the 100-year floodplain, and the total parcel value in Buncombe County. And so you can see that just based on county tax records, that we have almost $4 billion worth of property exposed to, this type of flood. Notice I said exposed, right? It's one thing that if property is exposed to something, it's another if you're actually vulnerable or at risk. So I want to talk a little bit about vulnerability and risk as well too. Vulnerability means that, even if you're exposed, you might not be vulnerable. I think there was a great article in the paper here recently about the types of building that's going on in the floodplains right now, and the ordinances and what the city has put in place to either flood-proof structures or move them up high enough to be out of harm's way. Well, the thing that we also need to look at for vulnerability and risk is supply chains, right? This is a picture from the 1916 floods, and we heard from the historians that one of the biggest things that happened was all of our supply chains were cut off, that we did not have ways to get relief supplies in, food. any sort of aid. I mean, all of the transportation was cut off into our area. All the roads, all the railroads, that things had to be brought in by people bringing in their back and by horses. And until we could actually get some of those transportation links set up, we were basically self-dependent, right? And they talked also this morning about, you know, the amount of livestock and crops that were wiped out. If you start disrupting your supply chains, your economy grinds to a halt. And that's really the biggest impact. We had a $200 million impact from the 2004 floods. Less than 25% of that was actually infrastructure. Over 100 million of that was business interruption, right? Not able to do business afterwards. And the disruption of the fresh drinking water supply line, lack of tourism coming in. Same thing happens after these, is how soon can you get your economy back up and working so you can actually get back to work and be self-supporting. This is the 5-county area, and this is a study that we did that looks at, you know, climate and our supply chains. If you look at every way into the mountains, into the city of Asheville, which is located right there in the middle, that whether you're coming up from Tryon or, you know, Lake Lure, or coming in across the mountains, across Black Mountain, or Madison County, or I-40, coming in all different directions, we have these pinch points that the mountains coming down or the water's coming up interrupt our supply chains. And just to remind you, the I-40 landslide in 2010, what sort of impact did it have on our local economy? Again, $200 million, business interruption. That, you know, it's a 100-mile detour to get around one of these pinch points. It's not like you're in Iowa where, oh, the road's blocked. I'll go a mile north, a mile west, a mile south, I'm back to going again. No, it's a little bit more difficult to do here. Also, the other parts of our supply chains. How many of you were here in 2008 and had to sit in line waiting for gasoline, right? The storm doesn't have to happen here to impact us. This storm disrupted the refineries, which puts all the gasoline in the Colonial Pipeline. That's where we get our gasoline from. And we're on the very tail end of that distribution system. And so if there's limited supply going into it, what usually happens is people are pretty smart. They're going to sell into larger markets, Charlotte, Raleigh, and they get the first call on the gasoline. We get later calls on the gasoline. But the city of Asheville has recognized that and actually has a good backup system to give us some supplies of gasoline during those pieces. This is a map that we've put together for the Southern Appalachians, but this becomes very critical in our decision-making moving ahead. We are all in agreement that coal is kind of the power source of the past, and we're going to be converting over to natural gas. Well, coal comes in by rail, and you can stockpile big piles of coal. And so if the rail line is cut off, you've still got that big stockpile of coal next to the power plant to keep the lights on. Natural gas is not the same. You cannot store natural gas easily, and it usually just is put into the pipeline. Notice what's happening here. Oops, I'm sorry. That this is Asheville. This is the tail end of a distribution system. There's only one way in for that natural gas, right? That if you disrupt this line, then we do not have natural gas coming into power our power plants sitting through here. So when you start thinking about supply chains in today's society and what drives our economy, there's one other big supply chain, and that's broadband internet. Our society runs off of the computer and smart devices. We also have more exposure now to this type of supply chain. So let's talk about then finally, this idea of what we're doing. Vulnerability is really the susceptibility of these things we care about. And you have to separate this out by people, our homes and livelihoods, or this critical infrastructure. And it's a little bit different than risk, because risk actually gets down to the probability of something happening and then the consequence or the magnitude of the loss. What made 1916 a major flood is it was a very severe event that had a major consequence, right? It impacted things across all of these sectors we care about. Large amount of human lives, disruption of the economy, critical infrastructure disrupted. So the consequence was very high. So if you start looking then at the probability of these sorts of storms occurring, we're seeing probability increasing, severity increasing. And so you have to be concentrating on the consequence side. How do we protect ourselves more? How do we lessen the chance of exposing more of the things that we care about to this loss? And that's what the rest of the speakers, are real experts in, is how do you get people out of harm's way? What are some early warning systems? How do you prepare people to move out of the way? How do you put less of your critical infrastructure in the path? And, how do you bounce back even quicker when you know these things are going to be happening fairly frequently? And so building resilience is about doing this. It's actually about taking those things we care about and trying to get them out of harm's way, and really increasing what we talk about adaptive capacity, making more resources available for recovery. And the panel this afternoon is really going to address this in detail, but I just want to give you a few ideas. This is from the main recommendations from the Asheville County Flood Mitigation, Flood Damage Reduction Task Force. And they really talked about these pieces, right? What are the three big parts? Is, how can we actually reduce flooding? So how can we keep that big amount of water all coming through Biltmore Village at one time? If we can keep it, flowing smoother. And so, remember what I said about just 2 years ago? Wettest year on record? We actually did a much better job of managing how the water was flowing coming into the Swannanoa from the North Fork Reservoir. And so the Swannanoa ran at bank level for what was it, 2-3 weeks almost, right? But it really never got out of the banks, right? If you would have put the 2013 rain events into our previous reality prior to 2004, you would have seen flooding in Biltmore Village again. But that did not happen due to being able to look at that. We're also trying to really look at this future build-out scenario. Let's just not keep putting things in place a lot more impervious surface. Education. A lot of what we're doing here, more of us know about what's truly happening and how we can work together. And then communication between and across communities. That we need to all understand that we all share these watersheds, and that things that we do in Hendersonville will have an impact on upstream because they're upstream. We've done a lot of buyouts and flood proofing to take things out of harm's way. This is close to the Muni Golf Course, just showing where the city bought out a lot of the properties. We can go into Biltmore Village, and where new buildings were built to replace the old Exxon station and a couple of the flooded businesses. These have now been raised up out of harm's way. There's parking garages underneath them that have openings on either end so that when the waters come up, they'll flow underneath the building without actually getting up into the business themselves. The buildings won't act as dams. So, in summary, our exposure and vulnerability are still high. That's just where we live in the mountains. It's the type of weather and climate that we have. The flood exposure is up, but really local vulnerability is down. And I have to say, depending on county, remember it's not just the floodwaters coming up, it's the mountainsides coming down. And Buncombe County and City of Asheville have been very proactive in a steep slope ordinance. A lot of our neighbors have not. And the North Carolina Geological Survey and some private companies are doing some really excellent work mapping about where the landslide hazards are. But it's getting that information out and getting policies in place to work with that. Our supply chains, we're going to continue to be exposed to that. And we really need to be paying even more attention to our supply chains And this then starts crossing municipal boundaries. But our risk is lower. We're better prepared. And even though the frequency and severity of storms is increasing, really the consequences are not. So with that, I will basically say, we are doing a good job, but we need to do even more.